Hey, so welcome back, and this is another daily LeetCode problem. So today it was called number of enclaves. So let's take a look at it. So this is a medium level graph question, and so you're given this two-dimensional matrix here called grid, and where you want to output an integer. And so all that you want to do is find out how many land blocks here. So yesterday's question was actually the opposite, where like the ones represented water and the zero was land, but they actually inverted it this time. So this time ones represent land blocks and zero is water. And so you want to return the number of land blocks that don't touch the boundary. So in this case, it is like 3 here. And so you don't count this one because it's touching the boundary there. And so for this one, we return 0. And so that's because if any of them touch the boundary here, then you automatically want to say, okay, the whole block itself won't work. And so you just set them all to 0. So you don't even include like this one here and this one here, because as long as one portion of the island is connected to the boundary, then it won't work. So there's two kind of popular approaches that you can solve this. One of them is to go from like the boundary inwards, and the other one's to kind of go from the like inside of the island outwards. And so like what you could do is kind of flood inwards and say, okay, anything that touches any land blocks that touch this boundary, let's kind of explore inwards and just set all of those blocks to 0. So in this case, we kind of go around the edges here, just outside of the boundary, the first kind of blocks in around these edges, and we say, okay, let's visit, once we encounter a land block, let's just like visit this entire island here and just set them all to 0. And so you can do this, where you just set all of these to 0. And so then once you do that and you kind of explored anything that attaches to the boundary, then you know, okay, any land blocks that are within this sphere here, we will say, okay, that is good, and we just count them all. And so in this case, maybe this might be a better example, you can say, okay, let's explore around the edges here, and we go around, we say, okay, this is a 1, so let's explore this island and set all the cells to 0. Well, there's only 1 here, so you only have to set 1 to 0. But let's do that. So we set this to 0, and then we say, okay, now let's explore all of the values that are in the middle here that don't connect to this edge, and just say, whenever we encounter 1, let's increment the count. And so we can do that. Okay, but for me, I kind of like a different approach, where you just iterate through this entire matrix here, and whenever you encounter a 1, you explore that island and just see, okay, if I can reach the exterior boundary here, then we won't include this count. And so initially you say, okay, we found 1 land block, let's explore it. So let's go right, nope, no land there. Let's go down, there's no land there. Let's go up, no land, so it's still at a count of 1. But once you kind of go out of bounds and you see that, oh, we're touching the boundary, then you say, okay, we're not even going to include this count, and so it's worth nothing, so we're still at 0. But when we explore this island, we say, okay, there's a land block here, there's 1 here, and there's 1 here, so we're at a count of 3. And so as we check every single neighboring block here from this island, we see that, okay, none of them touch the boundaries, so then we do actually include the count of 3. Okay, so this time complexity is just going to be like n by m, where it's like the number of rows and number of columns. And I think for the space complexity, it's the same thing, because we're going to want to have a kind of visited set to just keep track of blocks that we visited before, so we don't just end up in an infinite loop and keep recursively visiting them. So yeah, I'll show you the implementation for the second algorithm, but if you like the other one, maybe try implementing that approach as well. So let's go ahead, and so the first thing we want to do is just get the rows and the number of columns. just because we're going to be reusing these a couple times. So number of rows is equal to the length of the grid. And then this is how you get the columns. So now we just want to iterate through all the rows and all the columns. And all of this is just templated code that you write for a lot of these matrix problems. Great. And so from here, we're going to want to perform our depth first search. And so at the end, we're expecting to return like a total count. So we want to return that, and initially it's going to be 0. And so let's define our depth first search function. And we're going to want to pass in like the row and the column, like the indexes that we're looking at. Say we want to start exploring this node. And so the only ones that we're going to want to explore is when we find land here. Otherwise, we don't care about exploring the water. We want to explore these islands. So we only want to perform depth first search if at this particular location it's equal to 1. So then we want to explore it. And so now we only want to add to our count here. So if our depth first search function finds that, okay, this isn't connected, so let's return true if our island that we just explored is like not connected, and let's return false if it is connected, and so you don't want to include it. So we kind of can put like a if true, so like island is not connected, then we'll want to add to our count. So we'll do count plus equals. And so let's say that in this depth first search function, we're also, not only are we returning like true or false if we want to add a count, but there's going to be a count that will be incrementing while we're in here. And we'll call that like current count. And so before we perform our depth first search function, this initially would be 0, but inside of this depth first search function, it'll be incremented here, and we'll just add to our count as long as the island is not connected. Otherwise, we don't want to. Okay, and so we want to pass in the rows and the columns like we are. And so to get this current count variable, a common approach is just to define non-local and that variable name. And so that way you can get access to this and increment the count. Okay, so first thing that we want to do is we want to check, okay, have we hit out of bounds? And this is kind of our base case. Like once we go out of bounds, we don't want to explore anymore. And so we want to say, okay, if our row index is less than 0, then it's out of bounds. Or if the column is less than 0, then it's also out of bounds. I don't need to add that. Also, if it's equal to the number of rows, then we know it's out of bounds. Or in that case, also the number of columns. So any of these cases, we know it's out of bounds, and we want to say, okay, it is in fact connected. So hashtag island touches boundary. Otherwise, let's continue on. So if it touches water, then we know, okay, in this case, we didn't just find the boundary, so let's just return false. And so we want to return immediately once we see water here, because we don't need to explore any further beyond that. We don't need to look at the water's neighbors. We just need to say, okay, this is just water, and let's just return true and continue on. So if at this location it is just water, let's just return true. So island touched water. And so we also want to return true if we already visited this piece of land before. And so that, in that case, like, let's say that you explored this point, and then you go up, down, left, and right, and then you travel to this node. You want to make sure that once you're visiting this node, and you're looking left and right and up and down, you don't look at this node and then start revisiting this again and just infinitely doing that. So to prevent that, we're going to have a visit set. And so we want to add to our set whenever we touch land here. So visit.add, this particular row at this column. So then we also want to say, okay, if we already visited this piece of land before, let's just return true so we don't keep exploring it. So if this is in our visit set, or we touch water. Awesome. Okay, so from here, we're going to want to go in all the different directions, so up, down, left, and right. But before we do that, since we know that this didn't touch the boundary and didn't touch water, or we haven't already visited this piece of land, let's increment our count. And so we just found a new piece of land that we're trying to count for output. So let's increment this by 1. Great, and so from there, let's just say, okay, left is equal to depth first search, and we're going to want to go at this particular row, but to the column behind us. And then we'll also want to go in the right direction, so we just increment the column by 1. And then we want to say, let's go in the downwards direction. So we want to go to the row below us. Yes, this way. Oh, and these need to be minuses here. And then finally, we also want to go up. Or I think I got this reverse. So no, this is that. And then up is -1 because it's reverse when you're dealing with rows. Great. And then at the end of this, we just want to return. And so we need to make sure that in every single direction, these all return true. Otherwise, one of them touched the boundary, so we want to return false and not increment our count. Okay, and so to do that, we just say if left, return true, and right, and also our downwards direction and our upwards direction. All of these must have return true. So like hashtag explore island. And this is just visiting land block and incrementing the count. Great, let's try running that. And it looks accepted. Oh, we got a wrong answer, so we returned 23. That is not good. And so it didn't get very far. Let's use that test case. So let's see here. So our count plus equals, it gets reset here. We're incrementing our current count. And let's make sure that I'm using the right numbers. So I don't know how to lower this for some reason right now. There we go. So 0 is water, so that looks good. If row is less than 0, yep, makes sense. Are these right? Left, right, down, up, yep. Oh, I need to add +1 here. So that's definitely one issue. There might be another, but we'll try fixing this. Oh, that worked. And it worked this time, so just a small issue. Basically, if we just look at here, I just had to change this so that when we're going right, we add to our column. So sorry if that confused anyone. But yeah, once again, this is n by m, where that's like the number of rows and number of columns for the time complexity and also the space complexity, because we'll want to add to this visited set for every row, for every cell at every row and every column. And so that you have to have some space, but otherwise you'll just be visiting every island infinitely. So you need that. So yeah, I hope that helped. This is the depth first search approach, and I think it's pretty intuitive. It's just once you get this templated code and you practice a few of these problems, it helps a lot, and you'll see the patterns, and you just kind of have to take that templated code that and the patterns that you see and just alter it a little bit to answer this question. So yeah, I hope that helped, and hope you have a great day. Thanks for watching.